Good morning everyone. So this is your A+Tutor. So in this lesson we're going to be introducing a very important concept in physical sciences, which is vertical projectile motion, also known as VPM. Okay, so we're gonna start from a recap from grade 11 and grade 10, right? So we know that in grade 10 we learned about acceleration, velocity, and displacement, right? So we said that acceleration is the change in velocity over the change in time, and we defined velocity. We said that velocity is the change in displacement over the change in time, and then we define that displacement is the change in position. So in other words, we said that acceleration basically means how much your velocity is changing, meaning that let's say I was traveling at 6 meters per second, and then now I'm traveling at about 12 meters per second, so in that case, let's say initially I was traveling at 10 meters per second. This is my t0, and then my final velocity, now I'm traveling at 20 meters per second, right? After, let's say, 1 second, so t is equal to 1. So therefore my acceleration in this case is going to be a change in v, which is v final minus v initial. So this is vf minus vi over tf minus ti, right? So this is going to be v final is 20, and then v initial is 10, t is equal to 1. So therefore my acceleration is going to be 20 minus is going to be 10 meters per second squared, and then we have to indicate our direction because acceleration is vector. So that's how we defined acceleration, right? So it just basically tells us how much our velocity is changing over time. Like for example, in this case, I was traveling at 10 meters per second. Now I'm traveling at 20 meters per second. That means that every second my velocity is changing by what? By 10 meters per second, So that is what basically acceleration tells you. It tells you how much does the velocity change per second, yeah. And then after that we learned about velocity, right? Okay, I should have started with velocity first, but okay, it's fine. And then we define that velocity is equal to the change in displacement over time, right? But before I get to velocity, let me go to displacement, right? So I said that displacement, according to this, is the final position minus the initial position. So what I mean basically about this, I'm saying, let me make an example. Let's say this is position A, and then this is position B, right? So let's say maybe I go through position C, right? Let's say this position C. So let's say a person is going to walk from position A to position B, but he will pass through position C. Let's say you go this way, and then now go this way, So let's say this is 2 meters, and then this is like 3 meters, So for this case, the total distance, this is distance, right? The distance in this case is going to be what? It's going to be the total path covered. So it's just gonna be the total path that is covered. So therefore our distance in this case is going to be 2 meters plus 3 meters, which is equal to what? 5 meters. So the distance in this case is going to be 5 meters. So now the difference between distance and displacement is that the displacement does not care where you pass through. it just care about where you started and where you are going. So it only cares about the initial position and the final position. So it does not really matter if you went like this, like this, like this, like this, and then you arrived here. It does not really matter. For displacement, it's all about where you began and where you ended. So it's where you started, this is where you ended, right? So this is our displacement. This is our change in x, where b is x final because that is where you ended, and then a is x initial. So our displacement in this case is going to be x final, which is the distance, or the position at b minus the position at a, right? So that is the difference between displacement and distance. Distance is all about how much, like every we sum up all the part that you covered. Like in this case, you went from A to C, and then you went from C to D. So that is our distance, but our displacement only cares about the initial and final position, which is from A to B, where you started at A, where you ended at B. So that is what displacement cares about. And the other thing about displacement is that displacement is a vector, meaning that is a direction. What I mean about that is that in this case, since you went from A to B, your displacement is going to be from A to B because this has a direction. Whereas for distance, it does not really matter because it does not really have a direction. So we usually say that distance is just the distance is just the magnitude of displacement, meaning that you just take the number. So let's say maybe this distance was about, let's say, 4 meters. Our displacement obviously is going to be 4 meters, but then we have to include the direction, because if we say 4 meters, then it's like we're talking about distance. Because this person moved from A to B, then our displacement will be towards B, right? From A to B. So we have to specify the direction for displacement, right? So that is the main difference between distance and displacement, right? Okay, now going to my explanation here about velocity. I said that the velocity is change in x over the change in t, right? It's a change in position over the change in time. The displacement, you can call it as a change in position because that is basically what it is. It's just the change in position, right? So now let us look at this. So this basically means that it's how much your position is changing over time. Let me just make an example like I did with the acceleration one. Let's say you let's say this is A, this is B, and then this is C. These are like your 3 positions, right? Let's say this is about 2 meters, and then this is about, let's say, 4 meters, right? So this is t0, and then this is t equals to 1. This is t0 t0. This is t equals to 2 seconds, So what the velocity tells you how much is your distance changing, like how much is your displacement changing over time, meaning that how fast are you going, basically, because if you are covering a larger distance in 1 second, let's go to this example again. So this person was moving from A to B. He covered a total distance of a displacement of 2 meters, because remember, displacement is about the change in position, right? And then from A to B, the displacement is 2 meters, and then the displacement from B to C is 4 meters. So in this case, if you're gonna calculate the velocity between A and B and C, that is going to tell us in which range is the person moving the fastest. Okay, what I basically mean about that, let's take A to B, right? Let's calculate the velocity from A to B. So we know that V, which is a vector, is equal to the change in x over the change in time. which is equal to x final minus x initial over the change in time, which is basically t final minus t initial, right? So which is equal to, our final position is 2 meters, initial position is 0 because that is where we started, and our time is simply 1. So we get 2 meters per second. You see, when you say 2 meters per second, it basically means I covered 2 meters in 1 second. That's what basically means. I mean that I've just covered 2 meters but in 1 second. Imagine if this number was large, this one, let's say it's 10 meters. That basically means that in 1 second I covered about 10 meters, meaning that I'm moving very, very fast because I'm covering a larger distance in 1 second. Okay, let me just elaborate that one further. Okay, let's us remove this one, delete. Okay, so we know that our velocity in this case for A to B, velocity from A, this is VB, is 2 meters per second. You can, sorry about that, you can say that to the right because this is a vector, so it also have a direction to say to the right, meaning that the person is moving at 2 meters per second to the right? And then let's check for BC, right? We know that this is going to be the final position, which is basically what? So now we're not gonna move from A to C, we're gonna move from B to C, right? So we're checking how fast the person moving from B to C. So our final position, this is going to be 4, not 6, because we are taking it as if we are starting from B to C. So it's going to be 4 minus 0 all over. In this case, it's just gonna be 1 second, because we are taking as if we are starting from B, right? So then this is going to be equal to 4 meters per second, right? So now let us compare our velocities, right? Okay, so this is V, sorry about that, this is VBC, which is equals to 4 meters per second. So we can see that this person is only covering 2 meters in 1 second, whereas this person is covering what? 4 meters in 1 second. Imagine that. So this one is moving very, very fast because he's covering a larger distance in 1 second. So this one only covers about 2 meters. So he covered like 2 meters of distance in 1 second, whereas this one is covering a larger distance in 1 second. So that is what velocity is basically telling you. It's telling you that how much how fast is something moving, because it tells you how much of a distance is this taking per second, right? Imagine if something is moving at 100 meters per second. So that means that thing is covering about 100 meters in 1 second. That is usually like bullets and stuff, so that thing is moving extremely fast, so yeah, that is what basically velocity is telling you about, right? Okay, so let's move on now. We're gonna talk about two of the most important things from the recap, right? So we're gonna talk about constant velocity, right? So what do we mean when you say constant velocity? What we mean is that the velocity is not changing, meaning that the velocity that you are going with now and the velocity that you are going to be going with after, let's say maybe after 2 seconds, is still the same. Let's say I'm moving at 2 meters per second at t0, and then after like 6 seconds I'm still moving with the same velocity. They mean that my velocity is not changing. In other words, it is constant. So that velocity is constant. So that is what we talk about when we talk about constant velocity. We're talking about a constant velocity which is not changing, right? So from that thing we can deduce that if we are traveling at a constant velocity, that means that our acceleration is 0. In other words, if we're gonna look here, remember that acceleration is the change in v over the change in time, right? Meaning that if this is 0, then automatically this becomes 0, because if you divide by 0 you get 0, right? If you divide something by 0, right? Am I right? Yeah, but if 0 is on the numerator, then everything becomes 0, right? So if you're traveling at a constant velocity, then your acceleration is 0. This is the most important concept in metric. Once they say constant velocity, you have to know that your acceleration is 0. That thing does not have it's moving with the same velocity, so there is no change in velocity. So the velocity is not changing. That's what we mean when we talk about constant acceleration, right? And then let's talk about one of the most other like the one of the most important things also about constant velocity. So remember that F net is equal to ma, right, according to Newton's second law, right? Meaning that if our acceleration is 0, then our net force is also equals to 0, right? So we can deduce that if something is moving with a constant velocity, and then we can deduce that its acceleration is 0 meters per second, and therefore the net force that is acting on that object is going to be 0 meters per second. So these are one of the three most crucial thing in all physics in grade in metric, because you will come up with this word constant velocity a lot. You have to understand what this basically means. It means that the acceleration that that object is moving with is 0, and the net force acting on that object is also 0. Okay, as I explained here, that v is not changing, thus the change in v is 0, and since acceleration is the change in v over the change in t, that means that our acceleration is 0, right? And then the other thing that is the most important is constant acceleration. So what does that mean? It's meaning that acceleration is not changing, meaning that the acceleration is the same. So if I was moving with an acceleration of 2 meters per second squared after 1 second, that means that after 5 seconds I'm gonna still moving with the same acceleration, right? You will see how this will come in handy in this chart that you are doing, which is vertical projectile motion, right? So for the sake of this video, I'm just gonna end there. But the most important thing that you have to grasp from this lesson is that constant velocity means that acceleration is 0, and therefore net force is equal to 0. I've just explained that to you in detail. So in the next video, I'm going to be doing equations of motion. I'm going to be diving a lot deeper in the equation of motion. So yeah, that is it for this video. See you on the next video.